Okay, welcome to Unit 11, Lesson 1. This is all about systems of equations. So, first of all, what is a system of equations? It's really just a fancy word for two or more equations. We are going to do linear, and we are only going to do two in this class for right now. Okay, so there are three strategies, and you're going to learn all three in different sections. The first that we learn is by graphing. The second is substitution. And the last one is called elimination. And they all give you the same type of answers. So, types of solutions. There's three scenarios. If you have two lines, they can cross in one spot. So you're going to have one answer. The other type is if we have parallel lines. Well, the solution is the intersection. So if the lines are parallel, they never intersect, so you're going to say no solution. Don't write not possible, zero, that doesn't mean the same thing. And the third scenario is if we have one line and then we mathematically disguise it to where the other line is actually right on top of it, so it's the same. And that means that all of those points intersect, and so we're going to call that infinitely many. Okay? So, how to solve systems of equations by graphing. So number one is you want to solve both equations for y, but you want to graph both equations. Now, if you don't like graphing them, my strategy, you're welcome to do it any way that you feel comfortable. So number two is you're going to look at the graph and you're going to determine where the graphs intersect. All right, and that's your answer. So, since it is the intersection, if they intersect, remember we do need our answer as an ordered pair. So when you graph, you want to be pretty accurate. So let's do the first one. These are already isolated for y, so I'm going to go to my y-intercept of 4, and my slope is, I'm going to put the negative with the 3, so down 3 and to the right 2. And do a couple of points because that will help show you where they intersect. And I'll connect the dots. For these, since we are using graphing, we're not going to have any decimal answers because it would be impossible for you to tell. So these won't give you every equation. We're going to be pretty nice. The second equation, we're going to go down 4, and our slope is up 5 to the right 2. And you can see those points are together. So that's where we intersect. Our ordered pair is at 2, 1, and that's our solution. All right, let's do another one. Our intercept is 2, and my slope is 1. So I'm going to do a couple of points in both directions because we want it pretty accurate. And then my next one, I'm going to go down 3, and same thing. Now, even if I can tell what the answer is, since it says by graphing, I still do need the graph. Now, these never intersect, so I know there is no solution. Now, our last example, we need to solve for y, because I like slope-intercept for graphing. I'll subtract 8x and divide everything by 12. So y equals negative 2/3 is reduced by 4 plus 2. So I'll go up 2 and then down 3 to the right, down 2 to the right, and I'm off, but that's okay. Up 2, and that's pretty good. This I'll subtract 2x and divide everything by 3. So I'm going to go up 2 and then down 2 over 3. And you can see we end up right on top. So even though the equations didn't look the same to begin with, mathematically they are the same line. So this is infinitely many. All of these points on that line would be solutions. We don't list them out. Now, we don't need a graph. We should be able to predict, because remember, if lines are parallel, they have the same slope. And if they're the same line, we're going to see that mathematically. Oops, I forgot my x over here. So let's get these solved for y. I'm going to add y to the other side and subtract 1. On here, I'll do the same thing, add y to the other side, and then add 3. So let's compare. Well, these have a slope of 1, so that means they're going to be parallel lines. And so we're going to say the number of solutions, I'm going to say, is 0. Let's do this equation. I'll subtract 5x and divide everything by 2. Here I will subtract x and then divide by -2. Okay, so I look at my slopes. They're not the same. They're not the same line, so that means they should intersect at least once. They're just diagonal. All right, and the last one. We will subtract 8x divide by 12. All right, and I can reduce that if I need to. Subtract 2x and divide by 3. All right, so let's see. So I might have to reduce this. So divide by 4 and divide by 4. Now I can see those are the exact same equation. So we are going to have infinitely many. All right, so a point is a solution if when you substitute the point, it makes both equations true. If you substitute and makes it false, both of them, then it's not a solution. So this is our x and y values, and we need to substitute. So y is 3 and x is 4, and we want to substitute. So is 3 equal, well, -1/4 times 4, those cancel, is -1 plus 4, so 3 equals 3. That one is true. And let's check this one. 3 equals half times 4 is 2 plus 1. 3 equals 3. That one's true. So yes. So let's try this. So if we've got x is 1 and y is 2, is 2 equal to -3 plus 4? 2 equals 1. That's false. So I don't even have to check the other one. That's not true.